Okay, so I just looked on YouTube because I've just started these videos and thought, no, I wish I could find one, but I can't, so I'm just going to have to do these videos for you, which is good really, because you can see how I expect you to do it, which will really tie into your lessons. So, next bit, 27% as a fraction. It's already told you the fraction, because it's saying 27%, so 27 per 100, so 27 out of 100. Nice and straightforward. It's something you'll do anyway later on in the calculator paper. It's just that because it's on its own it might confuse you. Okay, so nice and straightforward. Percent per 100. The next one, write these decimals as fractions. It's really important that you know the headings of the columns of a normal number system. So you've got ones, tens, hundreds, and so on. Don't know why I put the s's at the top. But then you've got tenths, and then you've got hundredths, and then you've got thousandths. So when you put the number in these columns, you can see it's 9 hundredths. That's not very clear. I need to get a black pen. So it's 9 hundredths because the last number in that decimal is in the hundredths column. So when you remember those headings, that's really straightforward. Okay. Question 4. When we're rounding to the nearest 10, that 4 is in the tenths column, obviously. So it's either going to be 2540, so it's going to round down, or it's going to be 2550, sorry. And then because the first number to go was a 9, if it's 5 or above, we're going to round up, so the option we're going to pick is that one. Okay? So nice and straightforward. Moving on to the next one. In this space, draw a hexagon. Okay, I'm just trying to get this camera sorted. So a hexagon is a six-sided shape, but it does have to be straight lines. Okay, so you can draw a regular one if you want. So 1, 2, 3, 4, 5, 6. That's not a regular one. A regular one will look perfect. So all the angles will be the same, the sides will be the same, but it doesn't say a regular hexagon, it just says a hexagon. So that's a hexagon. Okay. And then we've got number 6. Find a number exactly halfway between, minus 4 and 10. So if you want to find the middle of two numbers, the easiest way to do it is add them. So 10 add minus 4, or minus 4 add 10, doesn't matter which way you get it. 10 add minus 4 is the same as 10 take away 4, which is 6, and minus 4 add 10. If you look at this number line I've got on the desk now, it's quite easy. So I was going from minus 4, which is here, negative 4, and I'm going to add 10. You can see I end up at 6 because I'm going to go that way. So that's easy to see. So that's 6. So once you've added them together, you need to halve them. So halve them. So the middle of those, whichever way you did it, was 3. So that's exactly halfway. And if you look at the number line, and you can draw the number line, there's nothing wrong with that. Okay, if you're struggling, you've got minus 4 there, and you've got 10 there. And as we come into the centre, you can see that 3 is actually in the middle. Okay, so that's exactly halfway. Okay, multiplying by decimals. The easiest thing to do with multiplying decimal is pretend it's not a decimal. So I'm going to do that instead. Okay, there's two ways. My preferred way is this way. But some people do the snowballing way, or the lattice method, or whatever you call it. So I'll show both. So 9 times 5 is 45, 8 times 5 is 40, 3 times 5 is 15, and then this method you add up the diagonal columns, so 4, 9, there. This way, this is my preferred way because you don't have to draw anything. 5 times 9 is 45, carry 4. 5 times 8 is 40, add the 4 is 44. 5 times 3 is 15, add that is 19. So you can see they both produced 1945. We made this 100 times bigger to make it that, so I'd have to make this 100 times smaller, so decimal point would have to go there. The easy exam technique is, in the beginning there were 2 numbers behind the decimal point, so in the end you have to have 2 numbers behind the decimal point, so the answer is £19.45. Okay, it's money as well, so think, does it make sense? If you've got a number where you're buying 5 things for £4 each, you know it's going to be roughly £20. You know, if you've got an answer that's like 2,000, then it's ridiculous. It's not going to cost that much. Just think about the logical world, the normal world. Right, this one. This did come up on our last practice paper. I think it was 6 actually. So here's part of an accurately drawn map showing two towns, Appleton and Blickford. So there we go, these two towns. The scale says every centimetre is 5 kilometres, so we'll need to know that. Find in kilometres the real distance between the two places. So I'm going to measure it. So I'm going to get in centimetres. So I've got 6.7 centimetres. So I've got 6.7 centimetres. That's the line. I mean, you can draw the line if you wish, just so you've got it there. Doesn't matter. Okay, and that's 6.7 centimetres. It says every centimetre is 5 kilometres. So if I had 2 centimetres, it'd be 10 kilometres, because I'd be multiplying 2 by 5. Okay, so I've got 6.7 centimetres, so I'm going to have to multiply that by 5. Okay, so the easiest thing for me to do there is just do 67 times 5 like you just saw. So 5 times 7 is 35, carry a 3. 5 times 6 is 30, add 3 is that. And then there was one number behind the decimal point, so I'm going to put one number back in my answer, or one decimal place back in my answer. So it's 33.5 kilometres. And I had to do that because that's what I was expecting. Okay. Right, Cookwood is a town 22 kilometres due south of Blickford. So south, obviously we know, is straight down in terms of that. So it's got to be 90 degrees to here. So it's going to be straight down here somewhere like that. It's going to be on that line. Okay. I think that's 90 degrees. I mean, if in doubt, I should get my protractor out and mark 90 degrees properly and then use that, but it didn't. So 22 kilometres is the real distance. And I need to turn that back into centimetres. So with here, if you look at this, I actually multiplied by 5 to go to the real thing. If I go backwards, I'm going to divide by 5. Okay, just like with exchange rates, you got to multiply one way, divide the other way. So I'm going to divide this by 5. Oh, didn't leave myself enough room. So 22 divided by 5. 5 into 2 doesn't go. 5 into 22 is 4. Remainder 2, so I've gone into the decimals now, so the remainder 2 goes there, and 5 into 20 goes 4 times, so it'd be 4.4 centimetres down this line. Okay, so go back to the diagram. 4.4 centimetres. There's 4, 1, 2, 3, 4, it's roughly there, and I'll give you some leeway, okay, with that, but it's roughly there. Okay, so it's quite a straightforward question. It looks like it might be a bearings question when you've got this north line on, but it's not. It's simple as that. Okay, so that's using scales on maps. And you either multiply or divide, depending on what you're doing. Okay, the next one, question 9. So this question can be quite frustrating for teachers because every day pretty much, or quite often, you'll go into shops with the same thing. You'll have a certain amount of money on you, and you don't want to get to the till and have to put stuff back. So you'll be calculating stuff as you go around to see that if you've got the right amount of, see if you've got enough money to buy what you're going to buy. Okay, so this is a similar idea. You're in a cafe, okay, and you're going to buy 2 teas, a coffee, 1 round of toast, and a bacon sandwich, and you've got £10. You need to see if we've got enough to buy it. So 2 teas, you're going to have to do 2 lots of 160. Okay, you've got 1 coffee, so just 225. So let me just actually work this out. So you can do 160. Add 160 if you want to. Okay, is it an easy calculation? So that's 12, carry 1. So that's £3.20 for those. Or you can just do those straight away, because you can do that times by 2. A coffee, what we got, so how much is a coffee? £2.25. £2.25, must be in a luxury cafe. Toast, £1.85. I mean, to be honest, coffees cost loads now. And a bacon sandwich is £3.30. Now, I used to go to Boulevard Cafe. Bacon buns were not £3.30, I can tell you that. Okay, so that is what we're going to have to buy. Oh, that's what we're going to buy. And if we're going to do anything with those numbers, it's to add them up, isn't it? Because you're accumulating the money, you're having to pay for all of it. So 0 add 5 add 0 is 10. So 0 carry 1. 2, 4, 12, 15, 16. I'm just adding them up as I go, making sure I included the carry number. 5, 6, 9. So it's £9.60. That's how much it's coming to. Okay, he has £10. It literally asks, does he have enough money? we've shown how we've got our answer, so we don't have to explain any of that. That's the maths has explained it for you, the process. But I need to comment. I need to answer now. So, does he have enough money? Yes, he has enough. And if you really want to put a cherry on top, you can say he has 40p change. Really shows you understand that he's definitely got enough, and you know by how much. Okay, so there's that one. Right, question 10. There are 9 cows in a bag. There are 2 red, 3 green, 4 blue. So we know there are 9 already. If they didn't give us that information, we should add these anyway, and it would come to 9. Lefner takes a counter at random from the bag. Find the probability. Now let's just get that down straight away. Fraction with standard probability. We're using fractions. Okay. So blue counter. There are 4 blues out of 9, and we're done. Okay. There's no common factor. We can't simplify. The thing that some of you were really worried about when you was doing your assessment is a white counter, or is there a white counter? No, there is not. So the probability of getting that is 0. Okay, you count 0 out of 9, but that is itself is just 0. Okay. Now this one's a bit awkward, and it was in the last one as well, where there was loads of possibilities. So I've got dice, so you can see what we're talking about. So it's saying you've got 3 options. You've got the pink, the yellow, or the brown counters. That you're going to pick one of these, and then you're going to roll the dice, and then what it wants to know is what are all the possible outcomes for that. What are all the options that you could have. So let's say I roll the dice. I've got a 4. Then I pick one of these, and it's a pink. Then that would be a 4 and a pink, or a pink and a 4. Okay. So she's going to take a button first. So I'm going to put the letters first, and then I'm going to put a number. So I could pick out a pink, roll the dice, and have a 5. So that'd be a pink and a 5. You know that there are 6 options on a dice, 1 to 6. So we need to know that. And there are 3 options in the other one. Because there's 3 options in one and 6 options in the other, we know there's going to be 18 options. Okay? So let's get on with it. So we can have a pink and a 1, a pink and a 2, a pink and a 3, and so on. So I'm going to make my examiner see these options in blocks. So I'm going to do all my pinks along here. So all the 6 options for a pink. And then on the next line I'm going to do the 6 other options for yellow. What I want to do is let them see my information in blocks of 6. They know I understand how these values go together. It's not random, and it's incredibly easy to mark. They can't shortchange me on any marks here because it's so structured. I've got to have these marks. Okay. Now, if you do it in words, there's no problem. Okay, but it just takes you longer. This would be accepted. What I'm doing now. And the official name for this is a sample space diagram. The way I've tried to set it out is all the possible outcomes. And if you do an official sample space diagram, you would be absolutely fine with that one. It would look great. Okay, so that's an easy 4 marks, that question. Okay, it doesn't rely on high skills. There we go. Next bit. So what we've got here, we have.
Morning, sir.
Morning.
How are you?
Living the dream, sir.
Same here, sir. I'm